Bismillahirrahmanirrahim. So far we have studied about deformation and elastic deformation and plastic deformation. So what is elastic deformation? It is the change in size or shape because of a force. Okay?
Yes.
Elastic deformation. What is elastic deformation? It is
Sir.
the change in size or change in shape due to an applied force. It means that a force must be there. For the deformation, a force must be there. ठीक है?
Yes, sir.
अच्छा, फिर हमने पढ़ा that what are the effects of force. So force produces change in speed. For example, if a moving ball it moves in a direction and somebody wants to stop it, so it can stop it with a force. ठीक शो? Same when you hit a ball that is coming from the bowler, so it through the force we can change its direction. So
Yes,
force
sir.
also brings change in direction, also bring change in shape. For example, we also talked about that if we apply force on something, so its shape, it distorts its shape.
Yes, sir.
Then we studied about deformation. That deformation is a change in shape due to an applied force. This
Yes,
is
sir.
because this can be a result of tensile force. या तो ये tensile force की वजह से होगा, या compressive force the वजह की देशी, या shear force the वजह की देशी, या the bending the वजह की देशी, या twisting the वजह की देशी. Then we studied about elastic deformation. So we studied that this type of deformation is reversible and temporary. ठीक शो?
Yes, sir.
As long as the force is there, its shape will be distorted. When you remove the force, so it will come back to its original shape. ठीक शो? But in plastic deformation, we say that when we apply more force and we cross the elastic limit, so the object, its shape is distorted permanently. ठीक शो? कल मुंगा पदा object बाने force लगो, और elastic limits नमुंगा सेवा दा force लगो. ठीक शो? Like a spring de amunga raka guno yo point pa vicha agena sewa ek tara ka gino aga biase shi kharab shi. ठीक शो? No ache kam je pure munga da bane da force lagu no daga da elastic limit te che de wapas pal original shape taratli shi. O kullak da elastic limit na munga force increase ko no bya bas ki da ki kam deformation razi plastic deformation. ठीक शो?
Yes.
No, in plastic deformation it won't be able to come to its original shape. ठीक शो? Then we studied today we are going to study about elastic deformation. That हम इसको मतलब प्लॉट किस तरह करेंगे, हम इसको ड्रा किस तरह करेंगे और ग्राफ के थ्रू समझेंगे कैसे. ठीक शो? नो लेट्स सपोज मुंग सरदायो apparatus आगे की यो मुंग सरा स्प्रिंग दे. ठीक शो? और 100 ग्राम स्लॉटेड मास चरता के फिजिक्स ता सुतले फिजिक्स लैब था.
No, sir. मुंगा allowed नहीं स्कूल का ये सब कुछ है.
हाँ फिजिक्स लैब के अलता मुंग सर दा से दा दुकानदारान सर दे अतले लिदरी के नहीं कि कहानी है 100 ग्राम 200 ग्राम किलो 2 किलो
सर क्लास राउडी की दा से सुना को बोतली नहीं हो चेरे दा था.
हाँ नो आगे के मुंग सर 100 ग्राम वाला दा कशांत की कहानी. ठीक शो? यो मुंग सर भी मीटर रूल मतलब आगाज कम घट मुंग सर दा नहीं आप रूलर लिदले दे चरता बल मुंग सर दे रिटॉर्ट स्टैंड. ठीक शो? दा मुंगा apparatus पकार दे ची मुंगा दा experimentally दा चे कम जमुंग दा elastic deformation दे दा मुंग स्टडी को experimentally नागे दा पारा मुंग सर दा apparatus पकार दे. ठीक शो?
जी सर.
नो दा उस दे के दल तके दे तगोरा दा मुंग सर रिटॉर्ट स्टैंड दे. ठीक शो?
जी सर.
दा चे दे दा मीटर रूल दे दा चे कम आगा फुट ते पदे मान दे दा लिखली कना 1 2 3 और 4 दा पे इंचेस किम भी और सेंटीमीटर्स किम पके भी और मिलीमीटर किम भी. ठीक शो? और
जी सर.
this is that spring and this is the weight. ٹھیک شو دا موږ سره 100 ګرام weights دي نو موږ به سو کو سٹارټ کیو elastic stand به واخلو هغه یو سایډ ته موږ spring وتړو او دا spring بلاندینی سایډ باندې دلته کې موږ سو کو دا load سکم دی دا weight دا ورته ورواچو ٹھیک شو
جی سر
then we will see چې دا spring بس کیږي it will go in this direction ٹھیک شو
جی سر
expand کیږي وکنه
جی سر
دیو په دې ډایرکشن کې لاندې expand کیږي ٹھیک شو
جی سر
نو اوس دا څه کې چینج راځي we can see
سر
that
د سایز کې
په length کې دې ټایم کې بده ته پس length کې مطلب وګدیږي وکنه length is actually what ٹھیک شو یو دغه نه واخله یو پوینټ نه بل پوینټ اپور چې څومره ډیسټنس دی ته موږ وایو چې دا length ٹھیک شو نو دا length په موږ سره کیږي دا به increase کیږي نو procedure کیسه دی arrange the apparatus as shown below ٹھیک شو
جی
measure the length of the unstretched spring before putting the masses to the spring مونږ به دا غي چې دی length باغه اول باغه ناپ کو چې دا څومره دی ٹھیک شو ان بعد مونږ ورته 100 ګرام ماس ورواچو او مونږ بیا دوباره چې دی نو هغه length په میجر کو length څنګه میجر کو
سر چې د میټر رول باندې
په میټر رول باندې ٹھیک شو and then we will add 100 gram more and then we will repeat the procedure and we will record the readings on the meter rule ٹھیک شو نو چې تا 100 gram weight یو پر واچي نو هغه بل کوم ته کې stretch شي let's suppose 2 meter هغه کې چې دینو 2 centimeter هغه کې change رالو په length کې لگاول 5 centimeter let's suppose دلته کې ځل لیکم کنه چې in the start چې unstretched length, let's suppose unstretched length was 5 meter. ठीक शो? Then चेकला मुंगा 100 gram put को न बिया मुंग सरा stretched length रालू.
जी
No आगा मुंग सरा सुमरा शो 5.2 let's suppose meter. ठीक शो? Again मुंगा 100 gram put को بیا موږ سره راغلو equals to 5.4 meter ٹھیک شو no you can see that there is a drastic change in its length ٹھیک شو like and how much change is it with when we add 100 gram so there comes a 0.2 meter change in its length
yes sir
so if again we add 100 gram so the stretch length will become equal to 5.6 yes 5.6 meter so we can say with 100 gram there comes an increase in length which is 0.2 meter
जी sir
ٹھیک شو
سر خو مونږ ته چې کوم فول نو آی چې لکه یو درې سلور چې ویټ واچو نو سلو زمزل باندې بیا نور نه لکه ډیرو به لکه 5 نو بیا 6 بیا 7 بیا 9 شو لکه
that is because when you go beyond the elastic limit then plastic deformation will occur ٹھیک شو یا when you add double weight for example زدل تک دا 100 پزے एकदम 300 gram واچوں سونا انکریز برازی بیا
سر بیا 5.6 برازی لکا
0.6 so you see تا بال تکی کتلی شکی دی شی حقیقی دغه کړي بیا ویټ چې دینو سیوا چولی یا چې دینو د spring elastic limit موږ سره دغه شوی یا
سر موږ ته سروي لکه چې دا شانتي 5.2 5.4 5.6 دا شانتي لکه رواني دا لکه وي Hooke's law دی لکه دا کوي لکه
او
دا د
به
Hooke's
کوي
law وبې کوي دا او وایي چې بیا لکه د خپل د elastic دغه نه بهر وځي نو بیا د دې د Hooke's law لکه بیا دغه بیا ډېر
بیا نه فالو کیږي
بیا نه فالو کیږي لکه ویټ په ډېر راځي بیا
واو نو دا اوس مونږ دې کې مخکې چې وګورو کنه نو مونږ ته به دا کلیر شي ٹھیک شو نو دا اوس چې دا سونه مونږه دلته کې سمرا دا ریډینګز مونږ واغستل نو دا مونږ سره پس کې دی په elastic limit کې دننه دي ٹھیک شو
جی سر
it is inside the elastic limit right now مونږ لا د elastic limit نه بهر شوی نه یو چې کله مونږ د elastic limit نه بهر شو نو it means چې تر دې پورې با دی ریډینګ پورې سوري دې ځای پورې کومنګا دنه دا فورس دا ویټ ختم کونو it will come back to its original shape
yes sir
it will come again to 5 meter ठीक so laka we can write here that by adding 100 400 and 700 grams we noticed an increase in length of how much meter? So 0.2, so 7 2s are 1.4 meter. So the stretched length becomes
6.4.
Yeah, becomes equal to 6.4 meter. But this is in the elastic limit. It is still in the elastic limit. Okay, so it means if we remove the weight, it will come back to its original length, which is shape, which is 5 meter. Clear?
Yes.
وای شو به چې ترسو پورې د elastic limit کې وي نو تر هغه پورې چې موږ سونه ویټ انکریز کوو نو د او هغه ویټ چې موږ لري کو نو هغه بس کیږي د خپل واپس خپل شیپ ته راځي خو دلته کې یو بل خبره ده چې if you see چې there is an equal stretch when we add equal gram of weight,
yes,
which
sir.
is 0.2. But when we cross the elastic limit and we add 100 grams even, so we will see an increase in length which could be like 0.6 meter. ठीक शो?
Yes, sir.
کوئی شو به نو دا غا کوېسچن دی چې کوم تا اوسو کو چې کله موږ elastic limit کراس کو نو هغه نه بعد چې کله موږ 100 ګرام ایون اډ کو نو بیا موږ له 0.2 میټر انکریز نه راکې अब موږ له سره راکې سیوا راکې او at that moment the spring چې دی it won't come back to its original shape.
Yes, sir.
Clear? کوئی شو به
yes, sir.
اوس Now, let's move to the next slide. Now you can see calculation. The load for every mass 100 gram is found to be using W is equal to mg because we always say that this change in length occurs because of a force. So what force is compelling the spring to stretch? It is weight. And weight equals to what? Mass into gravitational acceleration. Clear?
Yes, sir.
So weight will become W equals to
MG.
100 gram multiplied by 10 meter per second square. So weight becomes 1000 Newton. Clear? So by adding when we add 100 gram, it is producing 1000 Newton force on the spring. ठीक छो?
Yes, sir.
कोई issue पे करना?
जी, sir.
Okay, now the extension of the spring is the difference between its stretched length and unstretched length. For example, if you want to, let's suppose we say the stretch length in our reading, it was 5 meter. Clear? Sorry, unstretched length. It was unstretched length. Now, stretched length, it was after adding, let's suppose, 700 grams. It became 6.4 after adding 700 grams. Clear?
Yes, sir.
So I want you to find out the difference in length, stretch length and unstretched length.
1.4 meter.
1.4 meter is the extension. That is change in length. Change in length is how much? It is
1.4.
1.4, and we can also call it extension. You see?
Yes.
ठीक ना? So
yes, sir.
the extension and length is 1.4. And how did we calculate this? We just subtracted the unstretched length from the stretched length. Clear?
Yes. Yes, sir.
Da was yaad saate ha, the change in length or extension. Da ba yaad saate che mung sara ba hamesha munga ko farz ka find ko change in length or extension. So the formula should be stretch length
minus
unstretched length. Clear?
Yes, sir.
ठीक छो? Now let's move to the next slide now. Now you can see here that this was the original when there was no weight. Clear? Now we
sir.
added a weight of 1 Newton. You can see, and this is the change in length. Clear? This is what? Change in length. Let's suppose, let me change it right. This is the change in length due to 1 Newton force. Now we increased or doubled the force, doubled the weight. Clear? We took it to 2 Newton. Now we can see that the change in length is also doubled. Here it was 10 millimeter. Here you can see it is 20 millimeter. So how would you describe it? Is it in the elastic limit or did it cross the elastic limit?
So it is in the elastic limit.
Yeah, because we can see that there is an equal change due to equal load addition. Clear?
Yes, sir.
Okay.
Yes, sir.
Now, here is a graph. Clear? And this graph, we can say that this is the elastic limit. You see?
Yes, sir.
No, till the elastic limit, we can see that it is a straight line.
Yes,
Clear?
sir.
But
after,
bilkul, like with every 1 Newton, Hooke's law obey because it is in the elastic limit. Wait a minute.
Yes, sir.
Sorry. Okay. Now you can see that with 1 Newton, when the force or the load added to the spring is 1 Newton, so the extension is 10 Newton. From this point, can you see?
10 millimeter.
10 millimeter, yes. Now, when the load becomes double, 2 Newton.
So it becomes 20 millimeter.
Yes, let me change the color. Okay, so it becomes 20. And how can we read this? Because of this point. Can you see this point?
Sir. Yes, sir.
Okay.
It is a point of intersection.
Yeah. So you can see that there is an equal change with the equal load when it is added to the spring. Now,
Yes,
we
sir.
increased it to 3. So from the point of intersection, we can see that the extension becomes 30 millimeter. Clear?
Yes, sir.
And when we took it to 4 Newton, means we added 4 Newton force. So it became 40 millimeter.
Now
But
4.5.
now tell me what is the difference here. The difference here is 1. Clear? And it brought
Yes.
10 Newton difference, 10 millimeter difference here. Clear?
Yes, sir.
Now again, we increased 1 more Newton load and an increase of 10 millimeter has come in the length. Clear?
Yes, sir.
Now again, we increased 1 Newton more and we noticed that again there has a 10 meter gap. How? 1 plus 1 is
2.
2. Clear? So 10 plus 10 is 20.
20.
Now 2 plus 1 is
3.
3. And 20 plus 10 is 30.
30.
Again 3 plus 1 is 4.
4.
And 30 plus 10 is 40. So what can you conclude? That adding 1 Newton weight, we observed change in length. And what is the other word for change in length? Extension. Of how much? 10 millimeter.
Of 10 millimeter.
Clear?
Yes, sir.
So increasing or adding 1 Newton weight, we observed change in length or extension of
10
10
millimeter.
millimeter. Clear?
Yes, sir.
Okay. Now, but now let's see here what happens, because now we are going to cross the elastic limit. Clear? So
Yes, sir.
now the elastic limit lies here. It means that's the elastic limit. Clear?
Yes, sir.
Now we added 1 Newton more. Clear? So 4 plus 1 is 5.
5.
Clear? But look at here. The value is here for 5. So when you take it there, so you can see it is somehow like 58.
Yes, sir.
So we can see that it is like 58. Clear?
Yes,
So
sir.
what is the difference between 58 and 40? That is 18 millimeter. So now adding 1
So it
Newton
means it has
force.
crossed its elastic limits.
Yeah. So the change in length is not uniform now. It has changed. Uniform
Yes.
satawi ci yoshan change in length gura dalde chikala munga 1 Newton force at kulo no mung sara 10 Newton ba sewa ke do. O dalde chikala munga 1 Newton akhira ki 8 ko no mung sara 10 millimeter increase na sho mung sara sona increase sho
18.
18. नो چې کله هم تاسو را ریډینګ اچانک جمپ کی نو دا ټایم کې بتوي چې elastic limit is crossed.
Yes.
ٹھیک شو؟
Yes.
نو همیشه د elastic limit پورې با مونږ سره به دا چې کوم ګراف دی دا یو straight line وي. ٹھیک شو؟
Yes, sir.
او after that it will become a curve. You see, it is not a straight line now. See, that is.
Yes, sir.
Compared to this green line, it is not a straight line. It is a curve now. Clear?
Yes, sir.
Now after this elastic limit bamung sara sevi da ba hamesha mung sara curved line razi. ठीक है?
Yes.
Okay. Now let's jump to the next slide. Now conclusion. Now you can see that here it is 100 gram let's suppose 1 Newton force is added here. Clear?
Yes, sir.
And 1 is here. So you can see that is 1 Newton. This is 2 Newton, 3 Newton, and this is now 4 Newton. So till 3 Newton, we can see the spring is in a good condition. Spring बस a good condition के देखना. But when the weight is taken beyond 3 or it is taken to 5, so can you see the spring is damaged?
Yes, sir.
When the spring is damaged, can you say that it can come back to its original shape if we remove the weight?
No, sir.
Why?
Sir,
Because it is
is
damaged permanently.
Yes, sir. Just closed
And
its elastic limit.
yeah, the elastic limit is crossed, so we can say that from here to here, the extension and everything is an elastic limit. Clear? But crossing
Yes,
this point, this is now plastic. This is now plastic deformation.
plastic.
Wait, let me change the color. What color do you like? What is your favorite color?
So blue.
Blue? Okay. Which one? Sky blue or royal
Like
blue?
sky blue.
Okay. Sky blue. So this is now. So from here to here, this is elastic deformation. And here it is plastic
deformation.
deformation. Clear?
Yes, sir.
Which should be?
Yes, sir.
So now let's move to the next slide. Okay, can you explain this to me? We studied everything.
Sir, the bevel chilaka elasticity property tar dipore dalaka dipore to stretch ke no da bia khpal wapas khpal original length tar atle shi la khpal original shape ta وای
बिल्कुल
کدا elastic دغه دغه
limit cross شي
limit cross په نو بیا plastic deformation شي لکه بیا چې د خپل original حالت ته نشي راتلی original
बिल्कुल
form ته
बिल्कुल सही बिल्कुल دا yellow region چې کوم دی دا موږ سره کوم یو دی دا elastic deformation دی او د دینه بعد چې کوم region موږ سره start کیږي نو هغه موږ سره دا کوم یو region دی دا
plastic deformation
دا plastic deformation ٹھیک شو very well now Hooke's law. Let's study Hooke's law for a while now. So we can see here. Okay, 10 minutes class mein reh gaye hain. Chalo. Okay, now Hooke's law states springs were investigated by Robert Hooke nearly 350 years ago. He found that the extension was proportional to the stretching force. सोना मुंग सर बच्चे सोना फोर्स मुंगा सेवा को नो एक्सटेंशन बस कीगी सेवा कीगी बकना ठीक शो नो वी कैन नो दल तक मुंग सर दा डायरेक्ट वेरिएशन दे या डायरेक्ट प्रोपोर्शनलिटी द कना दा इनवर्स वेरिएशन आर प्रोपोर्शनलिटी डायरेक्ट प्रोपोर्शनलिटी दा सो फ्रॉम हियर वी कैन राइट हियर दैट एक्सटेंशन और this extension or change in length is directly proportional to the applied force. ठीक शो?
जी sir.
The more you the more you have the force or the force when you increase force, so what will happen? The extension will be increased. ठीक शो? When you increase the force applied on the object. So you will see that there is an increased change in length. ठीक शो? Now, this means that doubling the force doubles the extension. ठीक शो?
जी
चेमुंगा
सर
force double कुने extension बसशी double बशी. ठीक है?
जी
Using the proportionality, दामुंग सर proportionality sign दे. We can write extension is directly proportional to stretching force. पदे पोइशे? कि extension मुंग
जी
सर
सर
हमेशा से भी
so directly proportional the stretching force sir
और extension मुंगा पकम unit के measure को.
sir millimeters या meters
Millimeter means length के meter के. ठीक शो?
जी सर
और applied force मुंगा पसा के दगा को हुआ.
sir newtons
Newton. Now let's suppose munga denote ko length by x or stretching force by f. So we can say that f is directly proportional to x.
x sir मतलब
ठीक शो?
कच्चे
सुमरा force सेवा के दो ना बता सरा.
मतलब f is equals to kx
F is equal to kx. उस k ते संग रागलो because
sir
whenever
k
we
का formula sir the
when you
constant the para
yes chekala to da come sign de da proportionality wala direct proportionality da to change के equality था मतलब ऐसा लगे constant वाला लगे दाता मैथ की रूम भी चैप्टर वे लेकिन d2 की
जी सर
d2 की चिकम y is equal to kx वही ले देने
जी सर
दम
जी डायरेक्ट प्रोपोर्शनलिटी एंड इनवर्स प्रोपोर्शनलिटी
inverse proportionality no के मुंगा k value अक्सर find को no चिकला मुंगा proportionality equality ta convert ko no munga wa constant lagu age to mun k vayu no dal ta ki chikala munga da siliku che f is directly proportional to x so when we say f equals to x no munga bor sara yo lagu k is constant of what proportionality because it जगह से दामुंग सरा यो proportionality द पारा constant थी ठीक शो
जी सर
अच्छा now so it is true if the elastic limit if it is inside the elastic limit ठीक ना दामुंग सरा कला पूरी valid भी hooks ला चिकला मुंग सरा दा elastic limit के दनन है भी ठीक ना
जी सर
हाँ but if you cross the elastic limit so it won't be directly proportional to the force then it will be exponentially proportional then proportionality will become exponentially increase ठीक शो ब्याह मुंग सरा e power दा चुंके सादा level ना देखो ब्याह मुंग सरा देखी चिकम दगर राजी increase in length ना मुंग सरा exponentially राजी ठीक शो आगा भी डायरेक्ट प्रोपोर्शनलिटी के बयान नाराजी ठीक ना
जी सर
हाँ the graph figure 6.4 for a spring stretch beyond its elastic limit da munga already study को दल तक एक गोरा दादा यो ग्राफ थे ठीक ना सॉरी दा ग्राफ थे उस दे ग्राफ के तो गोरा छे देजे ना देजे पूरे दा elastic limit तो it is a straight line. It means when it is a straight line, it is obeying Hooke's law. But after the elastic limit, it is no more a straight line. So it is not obeying the Hooke's law. ठीक शो कोई शो परिवाने Hooke's law वांदे Hooke's law मुंगा सो which Hooke's law is actually what it is a law which states that within the elastic limit when you increase the force the extension and length will increase or we can say applied or stretching force is directly proportional to the change in length or extension ठीक शो but when you cross the elastic limit the it won't be following the Hooke's law then ठीक शो okay so let's write the definition here that Hooke's law states that within the elastic limit, the stretching force is directly proportional to what?
So it is directly proportional to
Change in length
to the
or extension.
extension.
So mathematically, we can write F is directly proportional to X and F becomes equal to Kx, where K is constant of proportionality. The Hooke's law will not be obeyed by the object if the elastic limit is crossed. Clear?
जी सर.
Hooke's law ترکمه پوری مونږ سره دغه بیا چې ترسو پوری elastic limit کی وی چې کله elastic limit ختم شي نو Hooke's law بیا څه شي
سر بیا با نه
فالو کی د دې سکرین شاټ واخله واده غستو
جی سر.
اوکې ناو ستار چندن کم دغه د کنه ټاسک دی
جی سر
هغه دا دی د دې سکرین شاټ واخله دا کوېسچنز
جی سر
واغستو دی
جی سر
او د چیک لیست د دیم سکرین شاټ واخله دا چیک لیست چې کوم دی
جی سر واغستو
ٹھیک دا نو دې کې به ته دا کوېسچن سیدی دی کې به ما دې کې به دا ته 1 2 دا بس اوکې صحیح ده
جی سر
د نن د پارستا صرف کم دی 1 and 2
جی سر
او په دې کې چې دین نو ته بس یاد کې دا recall the force cause a change in motion and recall the weight of a body of 3 دا first 3 points چې کوم دي دا به ته یو نوٹ ولیکې او ما ته بیا سند کې ٹھیک ده
جی سر د فرست 3 points باندې به نوٹ لیکم
واو بس 3 3 2 2 lines ولیکه ٹھیک ده او دا question به solve کی او د دې ورک example دغه واخله screen shot
سر غسل
دا به ما ته سبا explain کې ٹھیک ده
جی سر سر او تاسو براته دا هم نه خو سو میتھس بابا وی سر ورته میتھس
ٹھیک شو میت به ز شروع کما خو هغه بیا دا کار کو چې اله بیا بیل ټایم مختص کو ٹھیک ده دا میټینګ بند شي زه به خیر په واتس اپ کال کوم نو ډیسایډ وکړو چې څه ټایم